All right. Well, thank you for joining us for the Halloween edition of Perlmongers. Sorry for the mood lighting. We got kicked out of our normal space, and obviously they haven't changed the light bulbs in this place for a while. So this month, we're going to be looking at Docker in AWS. So basically, last time around, I created a little server program. I put it into a Docker container. And now I just kind of want to walk through the steps of how to get that Docker container into AWS. This is going to be just a very simple example because I discovered that even the simplest of things when it comes to AWS takes a lot of time. And as the demo gods, they've been very active, so things haven't been working. And I'll get more into that, and you're just going to have to trust me that it works. So again, what I built was my little Clash of Clan Notifier system, and I just wanted to kind of show it off this time around. Basically, it's, as we saw in August, it's just a fun little server. Ooh, written very small. How do I increase the font in IntelliJ? Oh, there we go. Thank you. So basically, just a simple little program that looks at a database. It tries to identify things that are done in the database, and then it alerts me. And I just wanted to show off that it definitely does work, which I didn't do last time. So basically, I'm in the directory with my Docker image, and I have built it before already. More bigger. So just built it real quick. Obviously, it's been pre-built. And now, more bigger. As you can see, I'm going to run it in daemon mode. And I've obviously created this. I'm going to, with the volume I'm creating, basically I'm taking the log file where I'm writing my logs to. Because it's a daemon, it's not meant to be inside of it. You just have to see it when you're looking at the logs. Unfortunately, I'm looking at the logs in the second screen.
You're doing a Docker run?
Yes, I'm doing a Docker run, -D in daemon mode. The --rm basically means that when I'm done with it, it will remove the image so that basically I can use the name again. If I don't do the --rm, the next time I try to run this, it says, oh, my COC notifier, that image is already taken. Then the -v just basically means I am mounting a volume from in the OS, the host OS, to clashofclansnotifier.log to inside the host, the var log clashofclans.log file. And so basically whatever gets written in the container will be seen outside of the container. You'll see that in a second. Actually, it'll be right here. This is the log output. So obviously, let's tail the log, clear that, and we'll go ahead and do that. So Docker is up and running. It says it's in that container. I can confirm that it's running. Oh. And it just messaged me saying that something's ready. In fact, I will finish this whole run real quick. So Docker PS shows me that I have a Docker image running. Its name is my COC notifier. It's been up for 15 seconds, and the image name. So real quick, we can look at the log output. Basically says, hey, it's starting up, running, it's in a loop. It's inspecting the canon, so it thinks that the canon might be done. It found that it is done, and it sent me this text. That was the notification I just got through the Twilio API. Now I'm going to stop that, otherwise we'll be getting a notification every 2 minutes. As you can see, it went to sleep for 120 seconds. Right now, it's just a stupid sleeper. It just sleeps 2 minutes. The idea of the daemon will be eventually, it says, oh, the next thing is going to be done in 5 hours. I'm now going to sleep for 5 hours. Which the idea then will be to further make that an automated task. So, I don't need to be, my AWS self doesn't need to be up for 5 hours. I'm going to shut myself up and tell the scheduler to start me back up. Therefore, I'm not racking up any, I'm not paying pennies for the container to be running during that time. Anyway, so stopping. the container. It's just docker stop my COC notifier. And then that will kill that. So that was just the proof that it actually works. So back to the presentation. There we go. So this is basically a notifier. There's nothing automatic or magical about this. It is a database where I have hand entered everything. And when I start upgrading something, I click a button that says I am upgrading this. And I've told it ahead of time, this is how long it takes to upgrade this. I have silenced all the notifications in the game because I don't like that. But at the same time, I do want to know when only these upgrades are done. So I've written my own server to tell me when that happened.
Is it true then that you're getting the information from Clash of Clans is being sent to you by some interface that you have, like you're logged into Clash of Clans?
No, there's no API for this. I am the API. I'm the API. So I play the game and I upgrade, let's say, a cannon. And I see that, okay, I'm now at 4. The next upgrade is to level 5. It takes this much gold, and it takes this many days or hours. I actually put that into a database. So when I go to upgrade that cannon, I just click a button, and that starts the countdown timer. And then, of course, this notifier will then notify me when it actually is done. So how do we get in? What do we need to do to get something into AWS, or more specifically, a container into AWS? Well, we use the ECS. ECS, I'm sorry?
EC2?
No, it's an ECS. It is an EC2 container service, ECS. Yes, I know. It's actually really confusing because I look at that and I always think it's an EC2. What the container service is actually is a collection or a cluster of EC2s. It spins them up on an as-needed basis. Unfortunately for today's demonstration, it's a very little daemon. It only has one purpose. We only need one instance. There's no load balancing. So actually, my ECS will only contain one EC2. But
Load balance.
but yes, if you had a bigger application like a web server or a subscription service that's either pumping a lot of information out or taking a lot of information in, then you'll probably have a load balancer and what's the thing that makes sure that if you get overloaded, it'll spin up more instances? Basically there are products available that help you load balance, and also when your system gets stressed, it will create more nodes so that it can handle the load. Yeah, Elastic.
Load balancer? ELB?
Yeah, maybe an ELB. Anyway, these subjects are not covered today. We're just getting the Docker.
Scaling group.
Oh yes, thank you. It is an auto-scaling group. If you can tell, it's been this room is very much in style with this presentation. It's been a lot of fun today. Yes, these topics aren't covered today. This talk is about getting our Docker into AWS. And then basically over the next year, we will be looking at how to make that little Docker container basically a production-ready device, where we'll be looking at logging, we'll be looking at balancing, load balancing, and all of those things. But for today, and it bit me in the butt a little bit, we are just getting our one container into Amazon Web Services. So again, the ECS, as I was saying, it eliminates the need for you to operate your own cluster management, configuration management systems, or worry about scaling or management infrastructure. That is directly from the Amazon welcome page on ECSs. The idea is that you give them your container, you set up the rules, and they will try to run everything as best as they can, and then, of course, charge you at the end of the month. So what do you need for the ECS? Well, you need first you need a Docker container. And actually, it's not simply a Docker container, but I'll get into that in a second. But you need a Docker repository. So this doesn't use Docker Hub. You will create your own little Docker Hub where you can put in your own tags and images of what you're building, and you will manage it there in your own repository. Then you will need task definitions, which basically say, I have this image and I want to do this with it. And of course, none of that really works unless you've created a cluster. And the cluster has the ability to take the clusters and associate it with the tasks. And we'll definitely be going over all of these things. So as I said, I said containers, not just Docker images, because containers is just an idea, and Docker is the most popular version of that. Again, I'm not going to go into depth, but there are other container technologies. There's Rocket, which comes from the CoreOS guys, LXD from the Ubuntu guys, unikernels, which is all about getting it as small as possible, which is actually a really cool idea. And Windows is finally getting into the game with creating their own like Windows servers, containers type things. But basically saying you don't need to stick with Docker. You don't like Docker for whatever reason because they've put Swarm into their software or whatnot. You have other options, but I'm not going to try to cover those at all today. So the first thing with dealing with AWS is credentials. Like myself, I have my personal projects, I have work projects. They all have to deal with logging into AWS. So the easiest way to get around that you don't have to every time specify your access ID and your access key, is to create an AWS credentials file. Now the Amazon webpage does go into details on how to easily create this file, but it's basically just a text file, and that is what it looks like. Like any other configuration file, you can have many more values, but that's kind of the bare bones. So there we have a default, and then we have skeleton key, which is the access that I will be using for these presentations. So the easiest way to do it is basically once you are going to work on one project, you can just set the AWS profile environmental variable and set it to which one of these you actually want to use. That shouldn't say skeleton, that should actually say skeleton key to match what I have in there. That's a typo on the slide. Or in any commands, you can just do the -- profile. In fact, I'll be using that one just to kind of let it sink in. So I will be going into how to create this key in a second, because that bridges upon another key point that isn't really utilized in this, where you're just getting one single container up and running, but becomes very important once you try to create an entire cluster and an entire community of containers and orchestration to do one task. One quick thing I wanted to mention, because it bit me a few times today, is I had logged in through Docker into AWS, and I will be showing you that as well. And then I would try to run something later on, and at the bottom it says no basic auth credentials. If you run into that, that just means that your login has expired. You have to rerun the login. And sometimes the login lasts for hours and hours, and sometimes it's gone in 5 minutes. I don't know what the actual timing is for that. Have you had any experience with that, Dirk? No? Okay. But I'm just saying that even if you've just logged in, for whatever reason, something may have interfered with the credentials, may have wiped them out, and you may have to log in with them. So I just wanted to kind of share that with them, because at first I looked at it and I scratched my head, and it was just a little confusing. So to get into AWS, basically we're going to be spending a lot of time on the AWS page, because this is where the magic happens. So as I said, the first thing, if you want to be able to actually access AWS through the command line interface, is you need to go to this IAM. Stands for Identity and Access Management. So what we're creating, or what I've already created here, is I've created a user, and I made it part of the admin group. So we'll just go through this. We're going to add a user. Just call it foobar. And then we can, what type of access does it have? Obviously, if we're going to be using it from the command line, you at least need to give it this. You at least need to check this box, because this is what will actually get your access key, your key ID and your access key itself. And you probably, if you're going to have someone working with you and you just want them to work through the CLI and you don't want them to access this area, then you don't check this area. But basically, normally for your administrative user, you probably check both of these guys. So next for the permissions. And AWS tries to help out here because this is the interface, as I said again, if you are going to create one task or entity and it needs to talk to the load balancer, it needs to have those permissions. That comes through AIM. Those groups, those rules are grouped together, and they get the right permissions that way. There are 286 different types of of groupings that you can apply, or of rules that you can apply. And so you can get very specific on if you're going to hire on someone and all they're going to do is load balance something for you, you can give them access only to your load balancer. It's pretty cool. Obviously, it does try to give you some shortcuts into just showing you what groupings are available for all of these. For the administrator, you just want the administrative access. So once you go through this, obviously you get a chance to review everything. And upon creating the user, you are then given your access key and your secret key. I won't show that right now because I don't know how long it'll take me to delete this, and I don't want anybody out there 5 hours from now being able to access my account. But anyway, write these down somewhere safely because whoever has those two will have, or in this case, will have access to the FooBar user who now has administrative access over my account. So, but that's basically it. Once you have that, you go to your AWS consoles file, you insert that in under a new heading, whatever you want to call it. I called mine skeleton key. Hold on, let me just delete that user. Okay. And we're off to the races. So AWS has a ton of service, as you can see here, and fortunately they also have a nice little search bar. So I know that we're going to do an ECS, again an EC2 container service. So I just click on that, and I hope that I've actually cleared everything out. I have not cleared everything out. So if you will bear with me, let me delete this. So when you first go into here, there we go. To it? I know it's tiny, sorry. Let's go back into this. When you first come into here, you are presented with a very different screen. You are presented with the wizard, which should be here. Well, basically, there is a wizard for this. The first time you go in this, it's called First Run. I'm sure I could figure out some way of getting back to it. It's a great first step if you're going to create a web server of some sort. It will go through. And when it's done, it'll actually do all the steps for you. A lot of things that we will eventually be doing as far as making a load balancer and everything else. Things that we just don't need for today's presentation. And the other rub on it is that once you've done the first run, you'll never see it again unless you delete everything out of here. So, and it's just going to take a little bit of time to kill everything. So basically, as I said, the first thing that you're going to need is I bet you if I just did that, hold on. There we go. This is the way, also a little video if you really want to watch it. You can read all about it. It's great. This, again, we're not going to use it. I just wanted to show you this, but this just steps you through everything that you need to know. You can say, hey, yeah, we want to store container images on our ECR, or in an Amazon ECR, which is in something container registry. And also we want to deploy a sample application. I'm just going to say no to this because I want to show you the bare minimum of what you need. But the wizard is really good. It works really well, and it shows you everything that you need for a fairly complex example. So as I said, the first thing that we really need is a repository. So we just basically click on repositories here. We say we want to get started, and we give it a name, whatever we want to call it. It seems like you could probably create like a very generalized repository and can do all of your containers in one repository, but it doesn't seem like there's a limit to how many you can have in there. So it seems nice to just kind of create one per project. So I'm just going to call this COC Notifier. And as you can see, there's the repository URI right beneath there. But you don't need to write that down per se. I mean, you should. But the great thing is then it gives you here all the steps to get your Docker into it. And in fact, we are going to follow them right now. So the most important is this one right here, where it tells you this is how you can log in, or more importantly, how you get Docker to log into your ECR. Oop. So basically, I'm in my Docker directory, or when I say Docker directory, I mean I'm in the directory that has my Docker file. For this command, we don't need to be, but basically we just, oh, that's not going to work. I forgot I need to tell it. Oop, bigger? How's that?
A little better.
Better?
One more.
Okay. So I'm using the -- profile to tell it I want to use my skeleton key, because that profile has the right credentials to be able to log into the right Amazon account. So it's going to spew out a whole bunch of stuff here, and as you can see, it's Docker login. So this is basically telling, hey Docker, you're going to log into my AWS account, and it gives this wonderful encrypted key, which I hope is randomly generated, and I probably will be deleting that user anyway after this. And you just paste it in. Of course, you have to make sure that Docker is actually up and running. Hey, and login successful. Now, anything that I do with Docker, as far as pulling and pushing, it goes to my new ECR. And how can we tell that? Well, if we go back to here, well, I don't want to lose these commands just yet, but if we went right now to, I can duplicate this. So right now, there's my repository, and if you look inside, there's nothing in there. So now we're going to follow the instructions, basically build it, and we're going to give it a name. It recommends the same name of the repository, but you can give it any name. So boom, I built it. Obviously, a lot of it's already been cached. And notice now, these are Docker commands, so I no longer have to use the profile because Docker knows it's only talking to myself. Here, it's basically, I'm going to create a tag called the latest version of my image is going to go up onto my ECR, again, to this name with this tag. I'm not going to use those. Well, I just did. I believe that currently the code is set to actually notify me if it's running correctly. So I'm going to tag this image as on, as in the notifier is on. Okay? And then we just push it on up. And I don't want to push up the latest version. I want to push up my on image. And normally your tags are going to be version numbers. And this is how you keep track of it. This is, which revision are you going? I'm basically going to end up with two images up online. One is with it on and one is with it off. And while we're doing that, I will go and, sorry?
Why one is off?
Just so that I can show you how to deploy code in a very rudimentary way. So there we can see enable Twilio. In other words, it's right now, as I showed you when I ran it, it paged me, and that will also page me. So that will not page me. So basically,
I see. It's a version that's configured differently.
oh, there we go.
The off one will be configured differently.
Yes. So basically, yeah,
Deploy either on or off.
I have this flag here saying if it's enabled, go ahead and message me. If not, print to the log file that I've been disabled. So, and we're still pushing. So if you know anything about Docker, Docker does things in images and layers. It's always an image upon an image upon an image. So here it's pushing up all the individual images. I have just created a different version of this program, but I've only altered the one file. And you're going to see the difference here when I upload the second version of this file. As soon as this worked a lot faster from my desk, by the way. So I was just assuming that it would have the same speed during the presentation, which I should know better. You can edit this part out, right? So I guess. So basically, as I was saying before, here's my repository. Now, oh, we haven't pushed yet. We're in the middle of pushing. Well, that just takes all the thunder out of my cloud.
May I ask why are the container, the image names are always these opaque hex codes? Is there
So
any way to make those more understandable?
Not those. So I gave last year. I gave a Docker presentation, the question was, why are the image or the layer names hashes? And the short version is so you don't have name collisions. But there's also a good reason for having those. And if you check out that Docker talk, it does actually go into what you can use those images for. It's basically during the building of it, if something goes wrong, you can jump into each layer as need be. And it's actually really great for debugging. Okay, now that we've pushed it up, well, we'll see in a second that it's been pushed up. Really quick though, I'm going to build this the latest one, the off version. So you notice it went real fast because not really that much changed. And now I'm going to tag it with off. That one real quick. Now I'm going to push off up to the repo. Anybody going to guess on what's going to happen?
It's gonna be real fast.
Why is it going to be real fast?
It's only pushing a layer.
Right, and you will see this exactly why. Here's everything. Hey, they already have this one. Only the top layer changed. It only pushed up the one layer. So yes, the beauty of Docker in that instance. So now, when I look at my repos, oh, thank God that worked. So you can see I have two tags. I have on tag and I have off tag. Trust me, the rest of this will go a little bit quicker. Task definition, what is going on here? And obviously, as you can see, I already have two task definitions. And who cares, we'll just go through creating a new one. So basically, to create a task definition, it's literally, you click on that, you give it a name, like COC Notifier on. If it needed a role, if I could spell. If it needed a role, like you need to be able to talk to EC2s, the load balancers, anything, this is where you would assign it. This program needs nothing. It just needs to be able to broadcast out to the world. So it doesn't actually need anything. And maybe this might be my mistake. But anyway, then you can add a container. And basically, the container name is just it's just a name that you know it by. So again, I'm just going to call it COC on. The next important part is this thing here. It's the repository URL with the image, with the tag, which we just basically pushed up. It's this whole thing here, plus the tag name, which I will write in, because this one, obviously, I don't want to be the off one, I want it to be the on one. Memory, obviously, I don't need that much memory. The lowest I can go is 112 MB bytes. And then I don't need a port mapping. Obviously, when I want to make this so that I can SSH into it, I would have to do a port mapping for SSH. But for a production box, your ultimate goal is no access to the box. You want it to spin up on its own, run perfectly, go away, and repeat. Rinse, repeat, recycle. And there's actually a lot of things you can do, but really this is all you need to do. You basically just need to give it a name, what image it is, and the memory limit. And boom, now we have a task. We will have the task as soon as I say save, create. Now we have the task. We have a task for the on version and for the off version. So now all we need is the actual cluster. So we just go to the cluster. So basically, we've created a repository that stores our images. We've uploaded our images. We've created a task saying, when I want to do this task, this is the image that you're using, basically rules. And the rules can be very extensive. Here it's just I'm telling you. So there's not much to go on here. So I'm going to call this my COC Notifier cluster. It's an on-demand instance. That means I want it to be up all the time. You can also use Spot, which is basically gets you cheaper pricing if you were doing something like in batch form. I am a cheap person, so I will go for the smallest that they have available, the micro. Plus, it's a tiny, tiny thing. This instance, I only need the one EC2 for it because I'm only running one node. Again, if I were doing a load balancer and other things, I would need more because I would need, one instance for the load balancer, one instance for this, one instance for that. The amount of storage. 22 gigs is the lowest they'll allow you to have. I'm sorry if you can't live within 22 gigs. Well, I mean, you have a good thing. Again, if you were going to SSH into this, you could provide a key there. That I will let you explore later. This is setting up the network. Basically, all of these default functions settings should be fine for a simple example. So basically, and then that's it. The cluster is being set up. It is creating a new IAM policy for the cluster based off of the fact that it's going to be interacting with the ES2, with the ECS. Thank you for that, Derek. And eventually, it will get the CloudFormation stack up and running. So once that is up and running, we will know when it's done when we actually have one container instance. The reason why it will be one container instance is that when we went through the settings page, we told it we only want one. If we were, again, doing it with more complicated, we would have the number of EC2 instances or container instances as we would need. So obviously, the more complex the overall structure is, the more instances you'll have. Once, when this is done, you can go into your container, into your cluster, and now you have to start telling it about it. So there are two ways of telling it. You can either do tasks, which those are time-based or manual-based. So basically, if it's a batch process, it's only going to come up and run once. Then you would use a task. Service is for basically a daemon. This thing's going to always be running. Right now, mine's a very stupid daemon. It needs to run all the time because it's always asking, am I ready? Am I ready? Am I ready? Eventually, it could become smarter and it could be turned into a task and automated that way. So for the service, we say create, and we give it, these are the list of our definitions. Well, do I want the notifier on? Do I want it off? Or these will be tags. Do I want version 1? Do I want version 2? Do I want version 3? Again, I just chose on and off for clarity. The cluster that it's running on, I only have the one cluster. Obviously, the more complex your program goes, you could have several clusters. You could have a notifying cluster. You could have a web interface cluster, which that's the place where you would go to actually go and update the information. You could even, right now the database for this is running on an actual MySQL server, also in AWS, but not through a container. I'm just buying time for a MySQL cluster node. Eventually, you could even have it running here if you figured out a good enough way of turning things on and off, depending on how much you want to save or not. So this is my COC notifier. Number of tasks. So how many tasks can it run at one time? Obviously, simple thing. I only need the one task. This will be for if you have the, what did you call it? The elastic, making it bigger. If you have the auto scaling group, will be helpful here. And that's just a template being used that I just used the default for. So no ELB, we don't have a load balancer. We don't have auto scaling. Again, optional things. And I'm reviewing it, and that's it. We are up and running. Right now, my container is being spun up. If the demo gods will be gracious, my phone will be blowing up as soon as it gets up and running, and it's trying to get up and running. So this now, you can go look at events to see what it's actually doing. It is saying that it did start my container. I can look in here to see what's happening with it. to an extent. See, it's still pending, so something is going wrong with it. This is where we're getting into it, where I basically said, oh, logging is such a great topic. That will be our next thing that we talk about. How can you log in a good, production-ready way? And so I ignored logging here. I have great logging in the container. The problem is it's in the container, which I can't look in, so I can't tell what's actually wrong with it. So, it's good to always write your daemon with good logging. It's also good to have access to that logging. Unfortunately, you'll have to wait for our next discussion on how to see good logging. So good reason to be here next time around. Other information you need in here, or actually I thought it was in here, sorry. Nope, because this is the task. You are able to, under the instances, okay, so under the ECS instances, you can look at the container instance and actually get the IP address. Okay, so there's our public IP address for our cluster and our container, if it was actually something that would receive. Since this container is all about sending stuff out, then, that doesn't help us. So really quickly, with not taking this too much on, so let's pretend it was actually working and my phone's ringing off the hook. I don't want to be bothered overnight with this. So, or we have a deploy. There was a bug and we fixed it. Obviously there's a bug, but we haven't fixed it yet. This is where we get into our task where our task definitions come out to help. If we created a brand new build, we would have pushed up with that new build. So in here, we basically click this and we say, okay, we're going to update you. And instead of using the tag on, we'll use the tag off. And then you go through the same steps again. No load balancing, no this, update service. And basically at this point in time, it's spinning down the old container, which was set to on, and it's spinning up the new container, which is set to off. And this is basically how you do, this is the beginnings of how you're going to do your deployment pipeline. You have a code fix, you need it out there, you get it in here. So,
Can you make it
yes.
so that it can deploy one and make sure it's running before the other one spins down?
So the question is, can you do a sensical deploy so you don't have service interruption? With this tool, as I understand it, no. This isn't like an A/B or red-green, or is it black-red? I don't know. So it doesn't, yeah, blue-green. It doesn't, spin them up to make sure they're there before it takes them out. There is no load balancing here whatsoever. It's only the one service. Now with the load balancer, there we can get into that, and actually that will be part of the future discussion that we'll have, is once we have introduced a load balancer into this, and probably auto scaling, then we're going to talk about continuous deployment and uninterrupted deployment. But the first is, let's get our logs working so we can tell what's going on with this stupid thing. So, again, really basic introduction. It was one container doing one simple job. Nothing about balancing, and really nothing about, this is the beginning of like a microservice. You've written one thing that does one thing well, but now we don't have anything about redundancy or discovery or any of these things. These are topics that over the next year we will be covering to basically learn what is a good microservice and how do we do that in AWS. Again, there is definitely more than AWS, but it's just the one that I've been using the most. And it's just what I've been choosing, but there are other things available. Again, quickly on resources, the AWS page on the ECS is the welcome page. It basically has all the information you need, and we'll be pasting this with the video and the images on YouTube and on the meetup. This blog, whatever, by Yevgeny Brickman was really great in just talking about, hey, Amazon has its wizard, let me show you how to do it directly. So it was a good time. Great resources, and if you have any other questions, please let me know. And yes?
Okay, so you used the -v switch to specify a volume outside of the container for logging.
Yes, that was when I was local. I'm sorry. The statement was we used the -v to create the volume locally. Go ahead.
All right, so when you deploy that image, which expects to write to /var/log/cs/notifier, Where is it writing to?
Again, this was just trying to get the right screen here. So I believe, you were talking about this right here. Yeah, again, this was creating a local mount. There are ways of creating mounts in AWS. I would probably I don't know how to control those yet. Obviously, there are many ways, like you can use S3 buckets to say all of my Docker containers will use the S3 buckets. Again, this was doing for logging, just so that I could just really easily log within my application to a file and then see that log outside, so I didn't have to do any fancy tricks there. This, again, is not a production example. This is just my example. You would actually, instead of writing to a log, you'd probably be writing to maybe a Kafka stream or some type of an aggregator. Because, again, the idea, this is a simple example where you really only have the one node, but in a really microservice architecture, you're going to have 30 nodes, all doing the same thing. And if one of them is having a problem, you're not going to log into 30 boxes to look at log files.
And write a syslog, and then just aggregate everything to, I'll just specify a syslog server for them all to log to.
So yes, a syslog server is definitely also an answer. It seems like more and more you're going to these streaming type services, but that when we talk about the logging, we will be talking about the options that are available. Again, this is basically a development view of logging. This is when I'm doing it by myself where I have the one server. But yeah, and initially I thought that just doing this would be too little and we would be over with before I knew it. And the more that I looked into it, the more I realized no. Or like even with logging, I'm like, oh, I can just shove in logging on the side. And I realized no, even logging, something as simple as logging is just such a topic. It needs its one, even just with one entire dedicated meeting, it'll just be short shrift.
This Amazon service, can you just log into it through the command line?
Yeah,
Shell?
and that's basically what we did.
If you expose it,
Yeah.
If you've exposed it?
if you've exposed the port 22,
Oh, I'm sorry. You meant the container.
Yeah.
Yes.
The server that's running your Docker container, can you just log into it?
Yes. So
Play around with it?
the question was, can we log into the container? Definitely, if you exposed it, and as we were setting it up, there were places where I could have set up a port match. The reason I didn't is because I was so self-confident and I knew that my programming is flawless that I didn't need this, and then I got bit in the ass by it.
yeah, you very clearly said, I don't want to expose anything on this.
Right.
Including an 80 or 88.
Yes, and I really kind of showed you the ideal form of what you're trying to go for. Like my server is a notifier. It reads a database and then sends out when it's time. There is no reason when it's out in the wild for anything to go into it. And if you are doing something that, and obviously, if it's just your fun project, there's no reason to lock it down like a crazy man. But if this is a production thing for even a small company, you don't want downtime. You don't want to expose anything that anybody can take advantage of. And therefore, so like when in its idealized form, this program would have no entry. It would be a black box. If something's wrong with it, the log should be spewed out somewhere. You should be able to read it there, then replicate that on your own machine while you can deal with it there, and then spin up the next version of it out. So that's the whole reason of exposing nothing. But yeah, if it's a web server, you're going to expose port 80 and port 443 probably. If it is some type of a server that needs to accept information in from outside, you'll expose whatever port that is. But then for security purposes, you want to make sure those are the only ports you're exposing.
Let's say that you want to update your database to put new military hardware that you're developing assiduously there. So the MySQL database is inside the container.
No, the MySQL database that it's talking to is actually in a database instance of its own. So if, just to show you, so here, in here it's RDS, I think, yeah, for Managed Relational Database Servers. I might have to, and you can see database instance 1 of 40, and there it is. There is the database. and I went and I opted for a MySQL database instead of the RDS instance. Again, all of these things cost money. There are a few things that are on a free tier, so be wary when you are playing around. I mean, for the most part, you're talking about a couple bucks, but for an entire run. But yeah, so the database is totally separate. I've elected to have it simply out and alive because my interface to it is just a web interface, and I don't want to have to remember to spin this thing up every time I want to update it or look at it or yeah.
So if you had a web app with the auto scaling, and you had 18,000 users running the web app,
Oh yeah.
the web app would be living in a container, and it would talk to an external database in the S3 cluster somewhere, or EC2 cluster, like RDS, and AWS is going to handle all the locking to make sure that all 18,000 users see the same data.
Well, so talking about a bigger structure here. So yeah, if this were like if every Clash of Clans user had a login into this, and this is the web interface that we're talking about here, as in all its glory and beauty. As you can tell, I'm not a front-end developer. In this instance, yeah, you would have a lot of choices to make, and it really depends on how fast you want it to be, how reliable, and all that. So the way that I would think of it, you would probably have a dedicated MySQL or RDS node through that. Then, yeah, you would have a web service on a load balancer with an elastic. I don't know why I can remember auto-scaling, with an auto-scaling group. So that basically you would just have like the one or two web server nodes running on it, and then if all of a sudden a new character is released and everyone rushes to your thing, it would spin up to keep up with all those new. But Amazon would take care of that. As far as logging goes, that is kind of your decision. How do you want to handle the logging? And you can do some logging through CloudWatch. But again, we're going to get much deeper into that. So it's like every step of this is going to be your decision. And it basically comes down to how much money are you willing to spend versus your customers' happiness. So, if you really want your customers to be happy, you're probably always going to have one extra node out there that's not used at all. So if you get slammed, you have that one node to get filled up before you need to, so that by the time it gets filled up, you have the next one already up and ready to go. So, just because AWS actually does give you a lot of tools, and that's that's most of what makes this so confusing. You have all of these services available, and they do all different things, and they're adding constantly and refining and making better. And you have to say, which one of these am I going to go to? I mean, like under the database, am I going to go with RDS, which is Amazon's version? Am I going to get just straight MySQL? Do I want to Spring for Oracle? Do I want to how do I want to do load balancing? Do I want to use their ALB or their ELB? And there are tons of decisions here. So. Yeah, you can use Postgres as well. They do have Postgres. So anyway, I'm going to cut it off there, but I'm very happy to stick afterwards. Thank you for tuning in. And next time we'll be in some place with a little bit better lighting. You guys have a good month.